Well, Elon Musk has done it again. After revolutionizing electric cars, rockets, and even social media, he now wants to rewrite how we access knowledge. His new creation called Grokipedia claims to be the truth, the whole truth, and nothing but the truth, responding to a user's comment on the platform now known as X. So how true is that? Is it really better than Wikipedia or just AI with its own bias? Looking at Elon's recent creations like X, which aim to remove expression limitations for greater freedom on the platform, and his AI Grok. He's now doing the same with Grokipedia. And in his own words, for years, Wikipedia has been controlled by left-wing editors who distort the truth. According to Elon Musk, Wikipedia has an ideological bias. In his own words, Wikipedia is controlled by editors, and he's even publicly asked people to stop donating to Wikipedia, claiming its editorial control is extremely left-wing. And of course, Musk didn't just criticize. He said, "If no one else will build an impartial encyclopedia, then I will." That's how this platform Grokipedia was born, created by his AI company XAI, the same one behind the Grok chatbot that lives inside X, formerly known as Twitter. So what is Grokipedia? Well, Grokipedia officially launched on October 27th, 2025 in version 0.1, and though still in its infancy, it already has more than 885,000 art. The main difference from Wikipedia is that Wikipedia relies on thousands of volunteers who manually write and review articles, modify them, then others have to correct and verify if the information is accurate. Artificial intelligence does this automatically. Is that good or bad? We'll see. The engine behind all this is Grok, XAI's chatbot that generates and corrects texts in real time. According to Elon Musk, this will create a living encyclopedia that updates instantly whenever something new happens in the world. So how does it work? In Grokipedia, users don't directly edit articles like in Wikipedia. They can only suggest changes that the AI may implement. Several testers have already noticed something interesting. When comparing Grokipedia articles with Wikipedia's, they found identical similarities as if the AI had copied or reformulated them, which raises a big question. Is Grokipedia truly creating new knowledge or just repackaging what already exists? Clearly, like all artificial intelligence systems, it doesn't create new knowledge but takes existing information and adapts it to its operational framework. Obviously, once you have the necessary knowledge, you can start creating things. But if you're ultimately writing content based on something that already exists, if you're trying to create content like Wikipedia, which is mostly historical, there's little room for invention. And that's where Elon Musk's criticism of Wikipedia comes in. It's about the perspective you choose to present. Despite all this, Grokipedia could represent a massive shift in how we access information. It could deliver articles on very recent or specialized topics in seconds, something Wikipedia can't accomplish as quickly. So, what do you think? Share your thoughts in the comments below. Very well. Google achieves the world's first verifiable quantum advantage. A historic announcement has just been made. Google has achieved the first verifiable and useful quantum advantage in computing history. This marks a turning point. For the first time, a quantum computer has solved a real problem faster than any classical supercomputer, 13,000 times faster. So, what exactly happened? Google, through its quantum AI division, developed an algorithm called quantum echoes that runs on their quantum chip named Willow. This system performed a complex physics simulation that would take a classical supercomputer days or weeks, but Willow completed it in minutes. The most impressive part isn't just the speed, but that the result is verifiable and reproducible. Another quantum computer can verify it. That had never happened before. Quantum results were theoretical, but now they're measurable, repeatable, and useful. So how does the quantum echoes algorithm work? Basically, the process is based on a quantum protocol called quantum echo, where first a signal is sent to the qubits on the chip, second one of them is disturbed, third, the process is reversed, and fourth, finally the echo, or how information has propagated, is measured. This echo reveals how quantum information behaves within the system, something impossible to track with a classical computer. This method lets us observe quantum chaos, how a tiny disturbance spreads between qubits like a wave of information. So what is this actually used for? Basically, thanks to quantum echoes, the Willow chip can model real molecules. In the study, they analyzed two molecules of 15 and 28 atoms, and the results matched those from nuclear magnetic resonance, the same technology used in medical MRI machines. They even discovered details that classical methods couldn't detect. This opens the door to discovering new drugs by seeing how proteins interact, designing advanced materials, batteries, solar panels, superconductors, and new instruments that Google calls quantum scope. a microscope into the quantum world. Why is this so important? Well, until now, quantum advances were more theoretical than practical. With quantum echoes, Google has demonstrated a real, measurable, and replicable application, the necessary step to create useful quantum computers. And they've done it with a 105-qubit chip, superconductors with extremely high fidelity and minimal error rates, a key step for quantum error correction, the industry's greatest historical challenge. As you know, last year Google launched Willow, which could correct errors better than they occur, and today in 2025, they've achieved the first useful, verifiable algorithm. Google estimates that within 5 years we'll see real applications only possible with quantum computers. We're witnessing the dawn of the practical quantum era, no longer discussing theories, but a new scientific and technological tool. So that's it. Tell me what you think about this news, and I'll see you next time. Very well, today we're going to explore one of the biggest tech stories of the year. NVIDIA has announced NVQ Link, a technology that could mark the beginning of GPU quantum supercomputing. It sounds complex, but what's at stake is simple: the future of computing itself. For 6 decades, computing progress was guided by an unwritten rule: Moore's Law. Moore's Law states that every 2 years the number of transistors in a microprocessor doubled. But this has come to an end. Transistors simply can't get much smaller without defying the laws of physics. The world needs a new path forward, and that path is called accelerated computing. In this new paradigm, the CPU is no longer the only brain. It's joined by a new co-star, the GPU, a processor designed to execute thousands of tasks simultaneously. For decades, NVIDIA has perfected this architecture and built a universal language on top of it, CUDA. Thanks to it, millions of engineers can communicate with these parallel machines. And now NVIDIA wants to extend that language to the strangest and most powerful world that exists, the quantum realm. In 1981, physicist Richard Feynman imagined something seemingly impossible, a computer that could directly simulate nature, because nature at its core is quantum. And 40 years later, that dream is beginning to become reality. But there's a massive obstacle: qubit. The basic units of quantum computers are incredibly fragile, and any vibration, heat, or noise destroys the information they contain. The solution is both brilliant and monumental. Quantum error correction involves using dozens or hundreds of auxiliary qubits to protect just one. But for that to work, enormous classical computing power is needed, and that's where NVIDIA comes in. And NVQ Link is the missing piece, a direct bridge between quantum processors, QPUs, and GPU supercomputers. A data highway capable of moving terabytes per second thousands of times per second to control, calibrate, and correct errors in a quantum system in real time. For the first time, the two most powerful machines on the planet, the quantum processor and the GPU, can work as a single hybrid brain. But this isn't just an engineering achievement, it's a partnership on a global scale. 17 quantum hardware companies, from superconductors to photonics and trapped atoms, have joined NVIDIA in this effort. And the US Department of Energy has announced a collaboration to build 7 new AI supercomputers, all based on this hybrid GPU quantum architecture. National laboratories like Oak Ridge, Sandia, Berkeley, and Los Alamos are already working to integrate this technology into their scientific programs. It's literally a new infrastructure for science. But why is all this so important? Basically because it marks the beginning of a new era of discovery. With GPU-accelerated quantum error correction, we can simulate complex molecules, design new materials, discover drugs, optimize energy networks, or create new AI algorithms. The most revolutionary part is that there's finally a scalable path from today's hundreds of qubits to hundreds of thousands in the future. We are witnessing the birth of a new technological frontier, a step beyond silicon, beyond code, and beyond classical computing. The era of quantum GPU supercomputing has begun, and with it, a new chapter in the history of human engineering. Tell me what you think in the comments, and see you in future updates. Right, Google has done it again. They've launched something that could challenge all subscription-based coding platforms like Lovable or Replit, and it's called Google AI Studio Build. With this, you can create complete AI-powered applications without spending a penny. In this video, I'll show you how it works. I'll build a real app and tell you if it can truly replace the app builders we all know. So if you've ever tried building an app with AI, you know how the story goes. At first, everything flows smoothly, but just when the project gets interesting, boom. A paywall appears, credits run out, or you face $5,100 subscriptions or ridiculous limit. Google seems to have heard these complaints and released a free alternative that honestly works better than I expected. So yeah, this is what it looks like. And to access it, simply go to Google AI Studio and click on Build. Here we can write our idea, upload reference files, or simply speak into the microphone for the system to generate our complete application in seconds. It's powered by the Gemini 2.5 Pro and Flash model. It comes fully integrated with Google's ecosystem: images, video, search, maps, and more. So let's try something practical, an app that helps improve your YouTube thumbnail. I tell it, Create an app where I can upload an image, change the person's facial expression, and add a before and after comparison button. I click on build. On build and we'll wait. And well, unfortunately it seems the tool is down right now, okay? So I won't be able to show it, but let's continue with the news. And it also has the I'm feeling lucky option, okay? The most fun part, honestly, is that you click on the system and it invents an application for you. I got a crazy idea, like an intelligent culinary assistant for a refrigerator. As you can see, I didn't have to think at all, just try it out. Perfect for experimenting or unlocking new ideas. When you finish an app, you can simply get all the code, save it to GitHub with one click, or deploy to Google Cloud, or just share a public link for others to try it. You literally go from idea to application and users in minutes. Alright, let's have an honest comparison. And as you've just seen, not everything in this news has been perfect. First of all, aside from it not working, it's ultimately a tool that's in Google AI's experimental study, etc. And they themselves are testing different things. I'm going to hit build again, but as you can see, there's an internal server error, so who knows what'll happen, right? But basically, you're limited to Gemini models within the environment, which is already a limitation in itself. If you generate thousands of images or videos, you'll have to pay for model usage, and some faces or visual details still need work. But compared to Lovable or Replit, the big advantage is getting a working prototype for free, which is all you need for most personal projects or tests. So in conclusion, Google AI replaces Lovable or Replit. Well, if your goal is to test ideas, quickly teach, create prototypes, or experiment with AI, my answer is yes. If your goal is to create large or commercial projects, you might want to stick with your favorite tools. So for everything else, this is a new starting point. And tell me, what do you think of this artificial intelligence? The future has finally arrived, or so the marketing claim. It's called NEO, a humanoid robot that promises to fold clothes, water plants, and keep your home spotless for $20,000 or $500 monthly. It's either a domestic revolution or a dream being sold prematurely. NEO is a humanoid robot standing about 5 or 7 inches and weighing 30 kilos, silent, with tendon-like mechanics and a washable cover. The concept is simple. It lives with you and handles household tasks. Battery life ranges from 2, 4 hours, self-charging dock, and 3 key functions. Chores, organizing, folding, storing dishes, watering plants. It's a companion with natural conversation, home awareness, reminders, and autonomy to move, recognize objects, and complete tasks unsupervised. The pitch is compelling. Go to work and return to everything done. NEO remembers where things are, never neglects plants, and improves weekly through model update. For elderly people or those with limited mobility, the potential is enormous. It offers both physical and cognitive assistance in one device with a friendly, non-intimidating design. If you consider time savings, the economics of paying for task assistance could make sense for some households or care facilities. However, in recent press demos, many of NEO's actions were actually teleoperated by a human wearing a VR headset. Yes, someone in another room was controlling the robot like an avatar. In launch materials, when NEO operated autonomously, it was clearly labeled, and there were very few such scenes, opening doors, carrying glasses, and everything else was assisted. So in conclusion, there's a significant gap between what NEO can do autonomously today and what it promises for the future. The plan is to learn in real-world environments. If NEO doesn't know how to do something, you can activate expert mode, where a certified operator takes control, solves the task, and feeds data into the system so the robot can automate it next time. It's the same philosophy we've seen in other AI tasks. Launch early, iterate with real users, and improve models with deployment data. But that makes you, as a buyer, a beta tester of an expensive product that still depends on humans for many tasks. A teleoperator means someone sees your home through NEO's cameras. The company says operators are verified employees, that each session is approved and flagged, and that you can restrict areas or opt out of sharing for training. Still, there are reasonable questions. How is that data anonymized? What is stored and for how long? And what about errors in sensitive tasks like medication? So as we can see, the future is actually quite a bit further away than we're thinking. And right now, this robot, despite having the ability to move, even via a controller, is still far from being functional inside a home. It has a battery life of only 2 to 4 hours, which is quite short, requiring frequent recharging. It has issues with speed and clumsy slow movements with just adequate balance, limited strength for heavy objects, and heavily depends on teleoperation for many real-world tasks. There's a risk of promising too much too soon, as we've already seen with other AI products in 2024 or 2025. So in conclusion, NEO perfectly captures our technological moment, part science fiction, part work in progress. If you're an early adopter willing to be part of the experiment, it might make sense for you. For everyone else, the smart move is to wait until autonomy and data policies mature. So yeah, leave your opinion in the description. I hope you enjoyed this news roundup, and I'll see you in future videos. Bye bye.